Okay, finding K using a RIChE Conc table. So being able to use a RIChE Conc table, if you're given the moles initially before you reach equilibrium and the mole of one of the chemicals at equilibrium, then in order to find K, you need to set it up so that you can work out the equilibrium concentrations of all reactants and products, and then you can find K. So the information that we have are the moles before it reaches equilibrium, and then the mole of at least one chemical at equilibrium. This is on page 212 and 213. Heinemann's using X and 2X, which is fine if you've only got a 1 to 2 mole ratio. But if you've got other mole ratios, then you really need to be able to do it with stoichiometry, mole ratios that we do. So we'll do this one with mole ratios. So our example is you've got 2 moles, I think this is the old textbook, 2 moles of sulfur dioxide, 2 moles of oxygen, put them together and you make sulfur trioxide in a 10-litre vessel. So you've got some reactants and you put them in the 10-litre vessel, and then when equilibrium was established, you've got this much of that remaining. So calculate the value of the equilibrium constant at this temperature. Remember, the temperature is important, and I haven't written it down. Far out. Okay, so I've just said that calculate the value of the equilibrium constant at this temperature, and then I realized that somewhere along the line with transferring these from one PowerPoint to another, I've managed to lose the temperature that this was at. And at this point I can't be bothered looking up what the temperature would be. When we get to the K value, you could look it up, see if you could find what temperature this reaction would occur at and give you that particular K value. Alright, so first thing, you need to have a feel for which direction the reaction is progressing until it reaches equilibrium. So are you getting more forward reaction to make products, or are you getting more back reaction to make reactants? So it's fairly clear with this particular question that we don't have any products to start with. So clearly there is a net forward reaction. So your reactants are getting together and making products. Later on we'll do another example where we have an initial mix of reactants and products, and then we have to work out which way it's progressing. So we set up our table. Once you get used to this, you won't have to set up a table, but yeah, I recommend that you kind of do it to start with. So in the textbook it's called an ICE table, ICE. I was finding that we were, myself included, were forgetting to turn the number of moles that we worked out here at equilibrium. We're forgetting to turn those into concentration before we put it into our K, calculate our K value. We were just using those numbers. So now I've extended it and called it a RIChE rather than just a nice table. Because we've got 2 C's, I've changed this to CH. And I've included the ratio because we kind of use that all the time. So first thing is we fill in all our details. So it's a 2 to 1 to 2 relationship. We start with 2 moles of each reactant and no products, and after the reaction occurs, so after the reaction goes to the right, forward reaction, and you make product, your information has told you that you're left with, at equilibrium, 0.15 mole of sulfur dioxide. So it's gone fairly to the right. It's favouring the products. Alright, so we want to work out the concentration. Once you know the moles, you can work out the concentration. So we need to know the moles at equilibrium. So we need to know what's gone on with these moles and how much of that we're going to make. So the first thing that we need to do is work out how much of this has reacted. So if we started with 2 moles and we're left with 0.15 moles, then clearly 1.85 moles of this turned into sulfur trioxide. We need to work out how much of the oxygen has reacted with that in order to make that sulfur trioxide. So we want to know the amount of oxygen that's reacted, so it's a 1 to 2 relationship. So in the textbook they would have just halved this number. So we can see that that's what we're doing, with our mole ratio. What you want, what you've got, and how they go together. So it's a half of this, gives you 0.15 0.925 moles of that has reacted to form with this to form sulfur trioxide. I'll just summarize that to fit it in this here. So if we reacted 0.925 moles of this, and we started with 2 moles, go back, how much of that did we make? So it's a 2 to 2 relationship, so it's the same number of moles. So we've lost these subtracting from here, it's reacted, subtracting, reacted, and we've formed, so we've added this much. Okay, so we can work out, we did the same here. If we took that away from our initial amount, that's how much we have at equilibrium. If we take this away from our initial amount, that's how much we had at equilibrium. And if we produce that much sulfur trioxide, then that's how much we have at equilibrium. So knowing the moles that we have at equilibrium, we can work out the concentrations. I think we had 10 litres. So number of moles in a volume. Yep. So we've got 10 litres. So we've got 0.015 of that, 0.17 of that, and that much of that at equilibrium. So you can see why, by the time you set this up and you're thinking about it, and if you just did an ICE table, it's really tempting to just put those numbers in the K. So that's why I've changed it to a RIChE Conc table. Alright, so we need to put these concentrations into our K. Remember, our products are on the top to their mole ratio amounts. Pop the right numbers in the right spots. Make sure you square them. Square that, multiply it by that, divide it into this, and you should end up with this. So we're working out our units. 2 m's on the top, 3 m's on the bottom. You'll cancel out 2 from each, and you'll be left with an m on the bottom, which is 1 on m, which is the same as m to the minus 1. And I forgot, I was going to mention at the front that our mole amounts and our volume all had 4 significant figures. So our units here have to have 4 significant figures. All right, 7 minutes, sorry.